Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. We group 4 from the section 7. We will present about the bending of beam. So for the theory, I will explain it. Bending is a flexible process which have many different shapes can be produced. Standard die set are used to produce a wide variety of shapes. The metal is placed on the die and positioned in place with stop and gauge. In it held in place with hold downs. The upper section of the press, the rams, lowers and commonly produce the V-shaped curve. So next, when the bending is real life in an experiment defines the behaviors of the thin structural element subjected to an external force applied perpendicular to the element's longitudinal axis. In this experiment, the elastic modulus is calculated by measuring the deflection of the beam with the force is applied to the specimen and various points along the specimen. Next, in general, a distributed load change or concentric force or couple moment are applied. The internal shear and moment function of x will be discontinuous, or their slope will be intermittent. For example, in figure 1.4, the coordinates of x1, x2, and x3 must be used to describe the variation of f, v, and m along the length of the beam. Thus, the coordinate will only be valid within the region A to B for x1, B to C for x2, and C to D for x3. Next, we can see the figure 1.4. We can see the formula. So that's all from me. Thank you.
Assalamualaikum, my name is Muhammad Aiman bin Alias, metric number AD190121. And now I want to present to you the result of the experiment. For the first table is between load and deflection. Load in Newton unit and deflection in millimeter. This is the data for the experiment 1. Next, the second table is about span length in millimeter and deflection in millimeter. This is the data for the second experiment, and the last one table is about height and deflection of the test specimen. The test specimen dimension is in millimeter square and the deflection is in millimeter. Next is the observation of the experiment. For first, the barrels and the top of the gauge on the testing device are free to move horizontally. Second, it was discovered that 3 different specimens with 3 different stiffness were used. Third, in this experiment, 4 blocks of 5 Newton each were used. 4. As load increased, so did the deflection of the beam, but the length and dimension remain constant. Fifth, a previous observation was made when the experiment investigated the relationship between deflection and load, with a span length of 90 of 60 mm and a specimen size of 6 multiplied by 25. 6. When examining the relationship between deflection and span length, as the span length increased, so did the deflection. And for the last observation for this experiment, when the relationship between the height of the test specimen and deflection is investigated, as the height increases, the deflection decreases.
I am Muhammad Fazil Mosman and as will continue presenting about calculation. For experiment 1, we need to find the value of moment of inertia first. Then, at load 5 Newton, we calculate the value of Young modulus. We calculate the value of Young modulus for each load. After got all the value of Young modulus, we can find the average of Young modulus for experiment 1. For experiment 2, we list the value of moment of inertia from experiment 1. Then we continue calculating the value of young modulus for each length. To got all the value of young modulus, we can find the average of young modulus for experiment 2, which is 166.26 GPa. For experiment 3, we need to find the value of moment of inertia first, and we continue calculating the value of young modulus. The calculation is continued for each dimensions until we get all the value of young modulus for each dimension. We can find the average for experiment 3. The value is 185.98 GPa. Then we compare the modulus of elasticity obtained with the theoretical value. For experiment 1, we get 15.7%. For experiment 2, we get 20.83%. And lastly, we get 11.44% for experiment 3.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafiz bin Jamadi. I would like to present about discussion. The first one is graph of deflection versus load. The experiment was conducted to study the relationship between load and deflection. The results and graph reveal that the deflection is directly proportional to the load. When the load is increased, the deflection increases as well. The second one is graph of deflection versus span length. The experiment was carried out to investigate the relationship between deflection and span length. The results and graph that have been plotted show that the deflection value increased as the span length increased. The third one is graph of deflection versus height of test specimen. To investigate the relationship between deflection and the height of test specimen, the results and graph obtained show that as the height of the specimen increases, the deflection decreases. The importance to have several types of beams such as C-channel, angle bar, I-beam or hollow section. Engineers must understand that have knowledge about the load application, structural phenomena subjected to members, and parameters that control the structural capacity of a member of a specific project. After all, different projects have different situations that engineers must consider, deciding which type of beam suits the situation. Thank you.
Hi, I am Muhammad Ashraf bin Halim. We'll continue the presentation of my group. First of all, the importance of to have several types of beams such as C-channel, angle bar, I-beam or the hollow section beams. So first of all, the importance to have several types of beam is the load application, structural phenomena subjected to members, and the parameters are for specific applications, which means not all beams are suited for every different situations. This is because every situation has different type of load, which is point load or uniformly distributed load, or different moments and rotation. Next, we move to the conclusion of the experiment. First of all, the experiment objective is achieved. We are required to find several relationships in the experiment. And the first one is, as the load increases, the deflection increases. For the second experiment, as the span length increases, the value of deflection also increases. And finally, for the third experiment, as the specimen thickness increases, the deflection decreases. And the final part of the experiment is the recommendation. First of all, conduct the experiment in a stable environment, which means don't shake or don't even touch the table, as this will alter the result. Next, take the data 3 times and calculate for the average value. This will help you to get more accurate result. Finally, make sure to reduce the parallax area during taking the results by making sure that the eye of the observer is perpendicular to the scale of the data.